Dog's still throwing up. Okay. I want to welcome you all to our special event. We're really excited because we have, I think, pretty much everybody except for Rick to share their Antarctic experience with us today. So what we're going to try to cover is just cover a few of the program things and products, stuff that's been developed since we last touched base with you. And then we're going to go around virtually and have each of the participants reflect on your experience. If a researcher is here, we will also ask them to pipe in and share their perspective. And then we're going to talk about staying connected and addressing your needs, whatever they might be, and anything else that Judy and I think is worthy of sharing with you. And hopefully this recording goes well so we can share it with especially Kara and some of the researchers were interested in looking at it when it was all done. So one of the things that I don't know if you realize or not, especially you, all of you that are presenting in the next couple of days and into the future, you're welcome to use this slide if you need it, but you're part of an ever-growing group of participants. You can see that we are now up over 151 teachers that we've been working with and research teams. So that's pretty exciting. Not necessarily that many teams, but it's almost a 1-to-1 ratio. Some of the things that you might not have seen or remembered since your last contact with us, but if you've been sending lesson plans, and getting instructions from us, like I know all of Kara's are up. And I think that might be it for Antarctic. Or Kate's, do we have, no, who else do we have Antarctic lessons, Judy, can you remember?
I think not up yet.
Yeah, some of them we're still working on, and I know many of you are still in this process, but the Arctic ones, a lot of the Arctic ones are up, so you can start looking at the resource page and just searching for lessons. Also, as you're presenting, it's a good place to direct people to find things, especially other teachers, about anything Arctic and Antarctic. We've got a lot of lessons that teachers have all created. Of course, there's the project pages. We call the STEM experience reports. At their expedition reports, doesn't matter, they're all in the same place, so you can go there and look at all the reports. I think the last published one was Dominique's, is that right? I think it might be, because we're still working on getting all the Arctic ones we have up. And then products. There's a special area, if any of you are looking or somebody says, oh, I want to know more about the program, there is a products page, and all of this, of course, is accessed on the front side of things, but it covers the latest annual reports or evaluation reports for the program, and any products that come directly from myself or other ARCA staff. So it's not stuff that you've created, it's stuff that we've created. And I'll put up presentations and things like that as well. So that's a good thing. And then the media pages are always ever growing. So without further ado, we do want to hear from all of you. So this is our chance to hear from you and hear what you've been doing since you got back. And I know for some of you, it's only probably been a month even, you know, that you've been back in the classroom and trying to realize where you are and trying to figure this all out. But we want to see what stages you are with different outreach and lesson plans and anything you want to share about your experience with the rest of this group. Oops. So Kara's is first then? Okay. At the end, you're catching me off guard, Judy. Judy threw a zinger in there. I was expecting it to be at the end of everything, but now it's the beginning. Okay, so now this is Kara's, and she actually sent in a recording. And in order for us to do that, I have to stop this program and share the other one. So just hold on. Hopefully this won't mess us up too much.
Hi, Jim.
Hello.
Welcome.
Sorry, I'm on the road again, so sorry I'm late.
No
Alright.
problem.
Oops.
Glad you can join us.
All right, so I'm trying to get that on. Let's try this. Okay, hopefully this will work. I'm gonna move you people around.
Down where that sound at the very lower.
I know, you guys are just, your heads are in my way here. Can't get to where I need to go.
Hi, everyone. I'm so sorry I couldn't be here with you this evening. I've been looking forward to this webinar since I returned from my trip. I can't wait to watch it and learn a lot more about how you're connecting all of your very cool expeditions with your classroom. Anyway, I want to talk a little bit about the Southern Ocean Diatoms expedition. It was really an amazing learning opportunity for me. The title implies that we were investigating diatoms, but over the course of the 5.5 weeks at sea, the expedition became even more clear in terms of the focus. The work done before, during, and after the expedition combined the work of marine chemistry, microbiology, and molecular biology to develop an understanding of the interactions of diatoms and the biotic and abiotic factors that influence their presence in the Southern Ocean. So this was basically a way for us to collect water samples that included diatoms, to extract those diatoms and the water, and to study the water chemistry as well as the biological aspects of the diatoms and bacteria and a slew of other things. I could go on describing the nature of these experiments in the Southern Ocean and areas around the Western Antarctic Peninsula. As a person interested in anything related to science, the ocean, and boats, this expedition touched on many of my interests. I learned new oceanographic and molecular biology research techniques, developed a better understanding of biogeochemical cycles, learned about historical, geographical, and nautical information related to the Southern Ocean and the Western Antarctic Peninsula, and developed a greater respect for the use of chemistry and understanding the biological interactions in an ecosystem. This last point was probably the most profound for me as an educator. Chemistry has never been my strong point. In my pre-expedition paperwork for PolarTREC, I even identified this as an area of improvement for my teaching. I will never say that chemistry is something that I strive to include in my talks about biology, but it was important for me to find a way to increase my understanding of these concepts so that I could include them more in my classroom. I do understand the importance of it. It's just never been easy for me to try to combine the two in a way that I understand and can then pass on to my students. By the time I stepped off the Palmer in late October, I not only felt much more confident in my abilities to discuss the biogeochemical interactions, but I felt confident in my ability to incorporate it in my classroom on a regular basis, meaning there were so many different examples of. So now that I'm back to the real world, I try to incorporate my PolarTREC experience in my classroom as often as possible. Whether it is direct association with diatoms and ocean chemistry, or just polar regions, I try to incorporate stories, pictures, and experiences from the trip into my biology, marine science, and zoology classes. I've also really tried to focus on bringing in researchers and individuals that are working in the community that I can then use as examples for my students. They don't have to just hear the information from me. So it's really brought back that idea that I want more presenters in my class to show students what individuals are actually doing out in the field, instead of just reading it in a textbook or reading an article, to actually meet these people and be able to ask them about their field. When I was developing my lesson plans, I tried to focus on topics related to the expedition to develop lessons that can be used by many subject areas. So while the expedition focused on diatoms and ocean chemistry, the lessons focus on modeling and inquiry, so that they can be used even if you're not studying a marine-based topic. So they could be a good use for just talking about the scientific method or research in general. My lessons, as well as other lessons for PolarTREC alumni, will fit in my curriculum next year and for many years to come. Students, colleagues, administration, and the community have been extremely supportive of this experience and have shown great interest in learning more about the topics. I have spoken at a number of community events. I will be speaking at an upcoming conference for the National Marine Educators Association and some various other outreach opportunities because so many people have shown an interest in what I've been doing. So even though I'm back on the Northern Hemisphere and going to my job every day, PolarTREC is always a part of my day. And I'm very thankful for that. It's an amazing opportunity, and I hope that it continues to be a part of my day for many years to come.
Okay. Share. Okay, you will all have to top that now.
Lots of pictures.
All right, so we're going to go back to screen share. So that was a good one. And the reason why Kara's not here tonight is because she is indeed doing a big event in her school. All right. So this one looks like David's. Uh-oh, did we lose David and Meg?
No, I'm right here.
We lost the text.
Oh, no, mine has transitions.
Okay, so you'll have to tell me when I have to click again.
Okay, I can do that. 7H, crevasse structures in the McMurdo Shear Zone. It was a different experience, I think everyone is aware. It didn't go quite as we had all planned. But that aside, pretty interesting things. So just to give everybody a background on it, now that we're all together again, the Shear Zone is an area about 60 miles outside of McMurdo Station, where the McMurdo ice shelf is combining with the Ross ice shelf, and they're grinding against each other. The Ross ice shelf moves at a slower pace than the McMurdo ice shelf, and as a result, because of the two different they start to actually have the crevassing is not the same as crevassing that you'd find on a glacier, which is crevassing as a result of it going over an object of some kind or another. There's no object here in this case. The crevassing is all happening because the difference is speeds. If you could click.
Oh, it's so cool.
I know. I try. I gotta keep Dwyer. So that pretty much says the same sort of a thing there, but we're having a scene between the two. So modeling that development is important for the understanding of the students to make the difference between the ones that are on the glaciers as well as the one that's on the shear zone and what that means in terms of motion of the ice. So if you could click it again. Hey, somebody moved that over there. Did you modify my slide? Who modified my slide, Judy?
Sorry.
It's.
I had no idea that it was set up like this. I just was going with the slide right in front of me.
I was supposed to transition very nicely, but Judy was being very efficient. So here in this case, the shear zone development now is they're taking an existing lesson that already was existing in the PolarTREC inventory, which was using UBI and to show the glaciers themselves. And we did that. Lynn and I, Lynn did that over at Timberline, and we did that lesson together. And I've since then now modified it to work with this. So we've got the original lesson was Ubing down a PVC pipe, and you tested and saw how it moved and put things into the way, and you just saw how it all moved. If you've never seen oobleck before, glue and cornstarch. And it makes it into this slow molasses, basically, that can't stick to anything, which is great. So in the modified one, we actually take that same thing and we create kind of a shower, one set of oobleck coming in from one side and one set coming from the other side. They slam into each other and they grind against each other, roughly, it's model, as the two ice shelves do. See how the glaciers move and which one's moving faster, and also draw diagrams and take notes on development and the opening and closing of the crevasses as oobleck begin to move. It's actually really pretty cool. I need to write it all up, but it's to see it all happen. The hardest part has been trying to figure out a way for people to implement the X-shaped format in their classrooms. We've been playing around with how to actually cut PVC pipe in the right angles and make them pivot and use this, and it ended up being way more complicated than I think it needs to be. So we need to figure out a simpler way to actually do it so that it's easier, more easily implemented in other classrooms. Okay, so we can go on.
Next slide then.
Yep.
Sorry, David, you're going to find some changes in this one too.
She's full of surprises today.
I know. She's
trying to keep you on your toes.
I know, it's great. So when we actually got to McMurdo, the gal that's standing, that has the yellow jacket on, that's Lynn. She's in the X suspenders back. And in the far back, you can just see his bald head. That's James. And so they all were in charge of the robots. Lynn was, luckily, she was very happy about that. So she's looking at Yeti, and Yeti is next to her on the left-hand side. Those are the two robots that actually did the work for us out in the field while we were out in the field. So was to actually tow a towed GPR, which is ground penetrating radar, out into the field. It wasn't safe for us to go. They were light enough and easily replaced. If they did go into a crevasse, we could extract them using a helicopter or other such thing. They did not, in the end, go into any crevasses, so we didn't have to do that. So if you could click, Judy. So Yeti and Scotty were the products of a lot of work, and my students in robotics and that sort of thing, and a lot of engineering. So it was important for them to understand that the original design, the original ideas are not what they actually ended up with. So I have a lot of timeline work that I went and worked with Josh and James on the timeline so the students could see the evolution of robots. As well as the criteria that they had to meet in order for the robots to go out into the field. Show the students the robots. I show them the robots at the very end, and we talk about abstract form first. And we give them the requirements for what they are, and then they're challenged to actually design their own autonomous robots. They do program them, they may move, they make them pull a sled. They have to be, it's pretty interesting to watch the students actually make the robots. And then you can go ahead and click, it's gonna come someplace. I don't know where she put it, there it is. So robots, and we talk about the robots, and I show them Yeti and Scotty. And we talk about the timeline. We do talk with Josh and Jim, talk about how they managed to actually do this. And Josh and Jim give the students feedback on their work. Now, granted, that's not going to be every single time that students or teachers do this sort of a lesson, but I think it was really powerful in that case for Josh and Jim to also talk about it, since really, you know, the India 178 was about crevasse structures in the shear zone. And Yeti and Scotty were to study that. But so they got a little bit of the spotlight there. And I think that they really appreciated it. And it was really pretty amazing to actually see the robots in action. Most of my work is all done not with the data in the field. We were pulled out of the field due to Gordon's passing. But it was an amazing experience. It was a lot of fun. I was able to do some pretty amazing things while I was down there, both out in the field as well as when I returned back to station.
Very good. Okay. And anything you want to add about public outreach that you're doing? You're obviously at NSTA.
Yeah, I'm at NSTA. I've done a lot of stuff actually in my own little town of Longmont and Boulder, talking about what I did out there. In Longmont, especially with my students, I've spent a lot of time talking about risk. And we talked about that in the library, risk and science, in terms of what's going on, especially in Boulder, because Gordon actually knew a lot of people in Boulder because of the nature of CU Boulder. It's got a large amount of climate work, so a lot of people knew about it. So it was really powerful, I think, to talk with the students as well as the general public about risk. In a day and age where everything seems so safe and so easy, that it's not. And that our scientists and ourselves, we put ourselves at risk all the time in order to understand the world around us, and we feel that that's important. And so that's been a lot of my outreach in terms of talking about that, since I don't necessarily have the data to talk about. But in terms of lessons learned, I think honestly, risk was probably the most important. Had a firsthand appreciation for it that I probably never did before, at least in the science field. It was amazing and something that I will remember.
Okay, cool. Thank you. All right, let's see. All right, looks like we're underwater here, so I'm gonna guess it's Tim.
Oh, hey everybody. So I was participating in an expedition called Polar Gigantism in Antarctica. This was looking at using a taxon of arthropods called sea spiders to try and understand the physiology, the developmental biology, and the ecology behind a phenomenon called polar gigantism. That is something that is witnessed in Antarctica among invertebrate animals, as well as the Arctic and in the deep sea as well. And so I was working with a diverse team of researchers, some from the University of Montana, Art Woods, Brett Tobalski, and grad student Steve Lane, and some from the University of Hawaii, grad student Caitlin Shishido, and then the project's the principal investigator, Amy Murat. And so they were taking a diverse integrated biology approach to understanding why, in particular, sea spiders get really big in Antarctica. And they're not the only things that get very big. Certain kinds of swimming snails get big, as well as shellless snails called nudibranchs. They can get pretty big down there. Annelid, a few different types of annelid worms can get pretty large, as well as ribbon worms can get to be over 6 feet long. So it's a phenomenon that's actually seen in quite a few different taxa down there. But sea spiders are a great way to study this because there's over 200 different species in the Arctic, the Antarctic, and in the subantarctic. And so you can compare species that get relatively large to ones that don't get relatively large and start to understand questions about why all animals reach a maximum body size and what are some of the limits to that. So primarily, the work that I was doing was scuba diving with the team under the ice, and there's a shot of me there collecting sea spiders. That was largely the work that we were doing while in the water. It was collecting animals for physiological and developmental biology experiments in the laboratories. And so on the lower left of your screen there, you can see me working on a thanks for the pointer. Working with some respirometry chambers, wherein we can seal sea spiders into sealed containers, experimentally lower the oxygen levels in there, and watch their change in metabolic rate as by measuring the oxygen that's taken up by the animals as they're put under stress. So when I wasn't out in the water or out on the sea ice, I would spend days in my Big Red inside a cold room, inside a heated building in freezing cold Antarctica. So yeah, and that water is the same. The water in those containers is the same 29-degree water that's out in the field. So that was really interesting to me experimentally because I'd never really worked in physiological research before, and I also working with the team of researchers who were doing. Jamie Moran was actually looking at. Oh no!
I think you're back now. Sound better. Are you there, Tim? No.
Anyway, this team of yep.
Okay, go ahead.
Okay. The team of researchers was, again, sort of attacking this question from a number of different angles. And so it was really neat to see that integrated approach of a full research team kind of hitting this one question. And some really interesting findings came out of it. Art Woods found out that even though sea spiders don't have any respiratory organs per se, their guts run the lengths of their long spindly legs, and those actually flush oxygen back and forth, flush fluid, oxygen-bearing fluid back and forth inside their legs as a sort of secondary function of their what's a digestive structure. So that was something that's made Science News. I got a photo credit in Science News from one of my photographs from underwater, which was I guess it goes a little bit into the outreach world, but it was really neat to be able to contribute to the team's overall efforts in that respect, not just from helping out with the lab work, but also being able to add some pretty cool imagery to what they were to their outreach and to what they're putting into publications later on. So and that's just like a great shot of me with a helicopter that I liked. So next slide, please.
It is a good shop. I want to commend you on that. You actually have pictures of you doing lots of cool things, and they're great pictures. So
thanks. So these are all photographs from some of the outreach work that I've been doing lately, and these are from Polar Science Weekend down at the Pacific Science Center, which is the big science museum in Seattle, and they invite researchers from anyone working in the Arctic and the Antarctic to come in and share their experiences and their work in the form of demonstrations over the course of a 3-day weekend in early March. And so I piggybacked on with another Antarctic USAP employee, Alistair Turner, who's a phenomenal photographer and has been doing this for a few years. So Alistair and I were able to get ECW gear from a number of different sources. Alistair had this awesome, the Scott tent was quite popular with the 7 and under crowd down there. And I actually would get kids dressed up in a dry suit with the undergarment on and everything, like have them there sort of like sweating and like just kind of really super uncomfortable. And I'm like, yeah, so you want to be an Antarctic explorer? This is exactly what it's like. You're really uncomfortable for a lot of the time. So yeah, this kid got all the way in the gear with the tank and everything on his back. I've also been giving presentations locally to a number of different nonprofit foundations, as well as our local library, other school groups around. My own school group, actually, we had a snow day. The one snow day like we've ever had here in the San Juan Islands happened on the day that I was supposed to give a presentation, so I've had to reschedule. So other than in my classes, my larger school hasn't really heard about my experience yet, other than, anecdotally. So in the classroom, I'm still developing a diffusion exercise, a diffusion as a relation between surface area and volume, as it relates to water. In this case, it's going to be vinegar, and it's sort of a play on the old vinegar with agar cubes. I'm putting them inside of dialysis tubing of varying diameters and getting an idea of diffusion coefficients, which is an oxygen flux. In this case, we're not using oxygen; we're using vinegar, but the idea is the same. There's a series of diffusion chemical laws, chemical properties called Fick's laws of diffusion, and I'm still making an analog for this so that the kids can measure diffusion into cylinders of varying diameters. And then they're going to, generate some actual data so that they can calculate some, in this case, vinegar flux using fixed laws of diffusion. So it's a pretty simple, it's only got 5 different variables in it. The laws are something that, in theory, 8th graders could be able to process if you gave them all the right data, be able to plug them into an equation and come up with an answer. So that's one of the ones that I've actually been like, I'm still having a hard time with the precise protocol for how to make it work, because it is kind of, you're messing around with all kinds of like sticky dialysis tubing, which when it gets wet, and then the auger has to be hot when you pour it in. So I'm 50-50 on whether or not this one's going to pay off, but that's what I've been working on. In the meantime, some other things are just sort of targets of opportunity in terms of lessons have popped up. One of which is that if you freeze salt water, you get a very different type of ice than if you freeze fresh water. And that's, the ice in saltwater ice is a lot more porous. Even it's got a very low salt concentration, just like solid freshwater ice, but it's weaker. You can drip food coloring through it fairly easily, whereas you can't with freshwater ice. And that's actually an activity that I got off of the PolarTREC resources page. And another interesting phenomenon happens when you're scuba diving, and one of the kids asked me about this, and I hadn't really thought about it until they saw one of my pictures. But on the top of, and I have here a scuba tank that I just keep in my classroom. So, sorry, can you still hear me?
Yeah.
Here's the tank. Here's the silver part is the valve, and then there's a regulator on top here. And the regulator takes a high pressure of about 3,000 psi and steps it down to about 400 psi. And in the process, when you're diving in water that's so close to freezing, the regulator freezes completely over with ice. And so the kids noticed this and asked me why this happened. And I was like, oh, well, while we're studying gas laws in chemistry, this actually turned out to be a really neat thing that we could kind of calculate. We could calculate the temperature drop in the valve going from 3,000 psi to 400 psi, and explain right there why the regulator gets crusted over with ice when we come out of the water. So that was kind of one of those like teachable moments that I would love to develop into a lesson plan. If only in photographs. I don't expect everybody to have a scuba tank and a regulator with them in their classroom like I do. So that's what I've been up to. And I can't thank everyone enough for all the work that they put in, both my own research team, but also you guys as Janet and Judy and Sarah as coordinators for the PolarTREC program. Elaine Hood, who is our implementer through Leidos, and then the guys who we dove with a lot, Steve Rupp and Rob Robbins, and the rest of my cohort. You guys have been super supportive, and I gotta thank David for sort of like giving me a head check every now and again when I go and be like, what is wrong with this place? What's wrong with the internet? And down here in McMurdo, David's like, I don't know. I get great service. It's like,
trust me, if it wasn't for me, nothing would have gotten done in that lab. Again, this has just been a profoundly wonderful experience, and thank you so much for all of the support and the opportunity.
All right, good. Let me see who's still around here. Okay, sorry, I had to just check up on all of you. Let's see who's next. Thank you, Tim and David and Kara so far. Awesome presentations. Very interesting to hear what you guys are up to. Okay, now we're to Maggie.
Yeah. Well, hey. So I sent these 2 enormous slides, no transitions.
That's okay. We'll take them.
Gosh, I think just to echo Tim, what an amazing opportunity I've had to not only go on PolarTREC again, but to work and to be over Antarctica. pretty phenomenal. For me, getting down to the other pole, I didn't really have it on a list, but now I get to check it off. So for those of you that aren't as familiar with this project, it was entirely airborne, so I never did touch the continent. I got to see a whole lot of it. We did fly typically 12 hours a day, and we had great weather, so we flew most days. We would have to take a rest day, a mandatory rest day on occasion for the crew and for maintenance, but for the most part we flew a lot. So I flew 13 missions, which is apparently fly, and learned an incredible amount about flight, Antarctica, about remote sensing, and what's happening in the world with our ice thickness and extent. So Operation Ice Bridge also flies at the northern. Ellie, who's here with me today, my anesthetist, is talking about that with me tomorrow morning here at NSDA. So we're going to be presenting not just about the experience, but also pulling some of that data to share with teachers so that they know how to the data and use it in pictures. We were flying in this big beast of a DC-8, nice old plane and easily modifiable, nice old plane with 4 massive engines, which we would fly as a regular jet would commute to Antarctica from southern Chile at the very southern point near the Straits of Magellan, on the Straits of Magellan at Punta Arenas, and we would take off from the airport there and fly for several hours before we crossed the peninsula. We did take 2 extensive flights to the South Pole, but otherwise we would be focused on one or another of the priority flight lines that had been flown previously in previous years, and data also collected by a satellite. So we're trying to bridge the gap between 2 satellites, the data flowing on these flight lines and areas of importance. So the mission itself is really, really critical in our understanding of how ICE is doing right now. So a huge honor to be part of that. As you look at some of the pictures here, I've thrown in some pictures. The top right shows all the flight lines for the year campaign that I was part of. And so it shows many different flights. We're going to Western Antarctica, which is the left side, the lower left side with lots of to it. And that was an area that had a lot of glaciers that are thinning and moving very quickly outwards, which actually increases the extent of the ice in the area, which is interesting. But thinning, maybe because of the thinning and the associated loss of buttressing that accompanies thinning ice, that it's able to flow farther outward from the basically progress really quickly into a melt area. So that's a really interesting area for us to study. The bottom right shows some of the navigation around the South Pole. This was named the Hamilton Line shortly after Gordon Hamilton's passing in honor of him. So that was kind of a nice connection for to be thinking about that. David. You can see from that I'm just going to minimize this here for myself so I can see it better. You can see from that the plane has to maneuver in really interesting ways and around the 85th or 88th parallel, and then scoot right back up the middle. So what one thing that came from this for me was a real interest in navigation. So one of the lesson plans that I have built, working on uploading, relates to navigation in below where the satellites go. And so when we basically fly off the map, how do we know where we are and how to just get lost, run out of fuel, and die? So this was, of course, an area of interest to get that figured out. So I learned a lot about navigation and currently really enjoying that learning. As we circle, just learning about weather, the middle bottom picture with John Sontag at the helm there, figure out where should we go, where it's a perfectly clear sky. And he was he's sort of a magical person and has incredible knowledge in many things, including meteorology. So I learned about weather forecasting from John. And then this is communications on board the plane. And they're talking to the ground, they're talking to the people in the plane and to the pilots. So really interesting stuff to be understood there. Picture middle left shows the Crane Glacier doing some thickness studies on and presenting at NSTA about. Shows the sort of the chaotic crevassing in yellow at the edge of the Crane Glacier where it joins the Larsen Shelf, and then basically where it's deteriorated so much that it's calved off pieces and broken parts of that ice shelf. The sliver of photograph on the left in gray shows what it looks like to the human eye, and that difference in photographic image and remote sensing is really exciting and interesting to folks. And then my final picture just shows, in the center, shows one of our instrument techs, Brian, and that's basically what his seat was, right where he's like kneeling on his plane seat. So that's kind of his helm, and learning about the data and watching it stream in.
I have a question. The one on the bottom left in the communications, is that on the airplane?
That is on the airplane.
And the one next to it, that is like at the hotel or at a base?
That's the airport.
Okay.
Yeah, exactly. You can go on to the next slide. So, a couple of areas of real interest, as I mentioned, starting at the top left picture. This is a section of Thwaites Glacier where it has a lot of chaotic and severe crevassing. And the Thwaites Glacier is thinning really, really rapidly. And so we spent some time studying that. What I do have an image, I didn't include it here, of the remote sensing imagery of what that actually looks like. It's pretty neat, and so some of the scientists on board. So I've been able to stay in touch with them from the data. As we move across, is an image that you may have seen in the news that won one of the photographs of the year. That's a John Sontag's picture. Of the Larsen crack, which then on the very right top picture shows the radar image of the crack extending down about 500 feet. So that's been a really in the news if you've heard of anything about the Larsen Sea breaking up. And when we were there, it was 72 miles long. Quickly after I got home, it cracked further to about 100 miles, and now it's about 102 miles with about 12 miles remaining, holding that piece of the size of Delaware onto the continent. When that breaks off, that's a big old iceberg. So open for that. I had flags that my students had made that came on board with us, so that was fun. Flew over the south. Then I just have some images here of some of the outreach that I did in the center and bottom. I was fortunate to be able to talk to some schools in Chile, which was really cool because they're right there. So it does turn out that at this point I've talked to almost 1,400 people. So that's been really exciting just to see those numbers really add up. So my students, of course, have gotten the most out of me. But I'm continuing to talk, well, like tomorrow, and in Denver as well. So that's been a lot of fun. And my last I'm in touch with some of the navigators, two of the navigators that I worked with, to field check my lesson and to give me perhaps a piece of some navigation data, because I don't have anything like that to include. And the other lesson I'm working on has to do with the crack. And I'm not sure, I'm not 100% done, but just, and what we can, why it's happening, where it's happening. So working on that. Just playing with the NSIDC Operation Icebridge data through the data portal has been really educational, and I'm only partway really proficient at it all, but there's a ton that, so working on lessons on that. And that's the majority of my report on the slides, but I mean, it's it's transforming and exciting, much fun, and I'm so grateful to so many people, to NASA as well as PolarTREC for letting me do this.
All right, great job. Yeah, well, you're right in the middle of it all, it looks like.
Totally.
Great, really neat. Okay, I love connecting with you guys. This is fun to hear all these things. So I'm just gonna go with the handstand there. I don't even need to see the title, but this is Kate's.
That's me. Can you guys hear me okay?
Yeah, I'm wondering why your picture isn't showing up yet on my world. But, let's see. Go ahead.
Okay. So I had the privilege of going to the South Pole. I know Maggie got to see the South Pole. I got to walk around the South Pole and drive piston bullies on the South Pole, and it was an absolutely incredible experience. Just as a reminder, I was working on Project IceCube, the IceCube Neutrino Observatory. So they're looking for neutrinos, both astrophysical and atmospheric, which it was a very unique experience because, as you may know, the detector itself is built and very deep under the ice. So you get there and you can't actually see the experiment itself. But of course, really rich discussions going on about the data that's being collected and what the findings are right now. Calibration work, stress testing, things like that were taking up the majority of the time while I was there. We were also laying the foundation for ARA, which is also looking for neutrinos, but in a slightly different way. I believe, and Jim, correct me if I'm wrong, there were 3 ARA stations put in the previous years, and hopefully 3 more are going in the coming years, with several more kind of down the road. Is that correct, Jim? I'll assume it is. So we did a lot of digging, a lot of like really tiring manual labor. So you can see it says digging for ARA in the bottom middle. ARA stands for the Scarian radio effect. So looking for neutrinos using this signature sort of radio signal, whereas IceCube uses a signature sort of blue light radiation. So hopefully getting much higher level higher energy level neutrinos. And so the problem with this ARA equipment is if something's broken or if you need to recover anything that was put in this ARA station box, well, a few years ago, this box was like sitting on top of the snow and the ice, and it was, just out in the open. And although it doesn't snow much at the South Pole, it's a huge desert, the wind will drift the snow quite a lot. So the box that we're looking for was put in no more than 5 years ago, within the past 5 years, and that hole ended up being taller than I was. So you have to imagine you're digging, you're already tired because no one sleeps well because it's always sunny. So you're digging a hole, you're at high altitude, you're already tired to begin with, and then this hole is taller than I am, so I'm like bench pressing the snow over my head. It's like -20 degrees with a wind chill of -40. And so kind of all of these factors together led to a really unique experience that I don't think I've ever had in my life before. So just trying to help out the team with the ARA project, even though I was kind of there for IceCube, we had more to actually do physically for ARA. I was also able to get my hands into weather balloon launches, the South Pole Telescope looking at kind of early universe, cosmic microwave background sort of stuff, the solar telescope quite literally looking at our sun, which we apparently don't understand very well at all. Got to talk to the NOAA guys about climate change research, CO2 emissions, things like that. So what's really great about the South Pole is there's only 200 people there. And so you get to know pretty much everyone really quickly. And it's this really unique sense of community where, everyone's just willing to help you out and tell about whatever you want to know about. So in addition to kind of the more physics neutrino side of things, I was also able to get my hands in other fun research. You can see I do handstands everywhere I go. So the bottom left is the ceremonial South Pole. So behind there's the 12 flags representing. Oh, that means.
Sorry.
Sorry.
I'm trying to mute them. Mute. I can't quite mute them. Are you still there, Kate?
Yeah, I'm still here.
No,
Yeah.
I think is Elaine, if I had to guess. I can't. Okay.
So the bottom left is the ceremonial South Pole. It's really just there for looks. It looks really pretty. There's 12 flags representing the original 12 nations that signed the treaty. And then the actual like South Pole, like point at the bottom of the globe sort of thing, is the upper right-hand corner where we're jumping in the air like we're in High School Musical. So it was really unique to be able to walk between the different poles and do handstands at all of them, and just a really, really cool place to be. Also incredibly beautiful. I mean, you're doing some really hard, cold, tiring work outside, but you look up and you get the view at the upper left-hand corner. You know, that's not, it's hard to beat as far as the work break goes. One thing I did for outreach while I was there was to make a 20-minute walking tour of almost every room at the South Pole Station, which has since gone viral. Surprise. So someone posted it on Reddit, and now it has like, I think 140,000 views, something like that. The Weather Channel picked it up and made it into like a little short thing that they reposted. NSF reposted it. Like, it's been really cool to hear from such a variety of people that they enjoyed that tour. So even though it took me like 3 tries of internet for like over 3 nights, waking up at like 2 a.m. to upload it, I feel like it was worth it in the end.
I know, that's the way I think. I was like, oh my gosh, I can't believe she worked so hard to get that to us, and now it's, you know, like you said.
Yeah, it took a lot of support from Ronnie and Deb and Joed to get that uploaded in creative ways, because full internet. So if you go to the next slide,
all right.
I'll talk a little bit about the outreach. I've only been back for a month or two now. So I really feel like I'm kind of in the thick of getting things planned for outreach. When I got back, I was on a radio hotline that's like local to the area and had a full 1 hour of on-air time, which was pretty unique. We got to talk about a lot of different things about my expedition, which has prompted a lot of people to reach out to me asking more questions, which is awesome. Something kind of unique about my expedition, my substitute was Katie Sherry, who also went to IceCube for PolarTREC. So she was very informed. And so she was able to engage my students in really unique ways. So I came back, and in the upper right-hand corner, this is the bulletin board in the hallway that I didn't know my students were creating while I was gone. And so they tracked my trip every day in class, and were reading my blogs regularly. And we did a webcast and then additional G-chats and calls into class and stuff like that. So that was really nice to have her as my substitute. I mailed over 500 postcards. The woman who worked at the post office really loved me. And then I also, similar to Maggie, did the like fly your flag sort of contest. And I ended up getting over 200 entries and taking pictures of all of them at the ceremonial South Pole, which got cold after a while. But some grad students entertained my crazy thoughts of taking all these pictures.
Very good.
Yeah, so I have a lot of things in the works. Coming up this Wednesday, I'm doing a community night where it's actually not just me. I'm turning this back on the students, as they are relative experts on IceCube now. So my students will get a chance to present science to a public audience, which I think is a great experience for them, kind of in combination with my own presentation. I'm going to the Ice Cube collaboration meeting in about a month and a half. Just got that finalized, so I get to see my team again, which is exciting. I'm working on a superintendent seminar where I'll do a presentation in the planetarium. So they'll learn about the science from me, and then we'll watch a planetarium show about neutrinos, which is really nice. A few other poster sessions here and there that I'm working on. Thinking about NSTA with like a regional version of it. So a lot of things in the works down the line, but for now I'm focusing on Wednesday's presentation as it has come up quickly.
All right.
Yeah.
Very nice. Love it. And what's Festival of Minds?
Festival of Minds is a teacher-led kind of unconference sort of style, and I'm presenting with another teacher in my district who actually Kelly knows now, going on the National Geographic trip, this particular teacher going to the Galapagos. So we're going to present on field research in tropical and Antarctic regions together.
Nice. Okay. So that's going to be both a co-presentation.
Yes.
Cool. Okay. All right, very nice. All right. Looks like Josh. Are you there?
Yeah, I'm here. I'm just waiting for the video to load. There we go.
There you go. Maybe your name might change eventually. You won't have to be Kate anymore.
Okay.
It takes a while. So go ahead, Josh.
All right, so with my Tough Tardigrades project, we were focused in the dry valleys. So the pictures up at the top kind of give you a little bit of an idea of what the dry valleys are like. You can see there's a few little patches of snow dispersed around, but that's about all of the accumulation they get. They get a little bit more that sublimates off than that, but not much snow at all that accumulates in the dry valleys. In fact, this year there was kind of a sort of record amount of snow in one of our experiments. We were not able to do just because it was covered with about 5 inches of snow or so. So there was just a drift right on top of where we needed to treat the experiment. So, basically, well, we did a lot of helicopter support for our sample collection. We also relied on a lot of remote met stations. So right in the middle of the screen, you can see a soil met station there that's logging soil temperature and moisture and things year round. And then
Josh, wait, sorry. What's a met station? What's that?
So a meteorological station. It's a remote meteorological station. And so this one's focused specifically on soil. And so mostly what we did is we would go out in the field and we would collect soil samples. In terms of equipment, nothing really fancy. I mean, we had little plastic Whirlpack bags and plastic scoops, and we would just fill a bag with soil and take it back to the laboratory. We're looking at primarily the animals that are in the soil communities, and then as well as the abiotic factors that go along with that, and trying to understand the distribution of the different species of animals and how they're changing as the environment changes. So right now, for example, in the dry valleys, you can see a picture of the lake in the top center there. Most of the valleys have these frozen lakes in them. The very edges of the lakes thaw each year and form a moat in the summertime, but the rest of the lake stays frozen. But lake levels are rising rapidly. They even had to move one of the field camps up on the slope about 100 meters because it was going to be flooded in the next few years because of lake level rise. And so the environment is changing fairly rapidly, and they're just our team is primarily just trying to understand how that's going to affect the soil communities. We did some manipulative experiments. The bottom right 2 pictures, you can see that plastic cone-shaped structure is called an ITEX chamber, and they're used to warm the soil, creates a sort of miniature greenhouse. It only warms it by a couple of degrees because it's got an open top, but it does increase the warmth of the soil. We also treated plots with various nutrients. It's kind of interesting because nowhere else really in the world do you think about carbon being a limiting factor in a soil ecosystem, but it is in the dry valleys of Antarctica. A lot of the carbon that is utilized by the soil community has been fixed anciently and is just being used now, or is continuously being used by these communities. And so one of the fertilizer treatments that we use is a carbon fertilizer treatment, just to see how an influx of carbon changes the soil community. And then we also did nitrogen and phosphorus, more traditional limiting nutrient experiments as well. You can go ahead and change to the next slide.
Okay.
So once we collect our soil samples, they all went back to the lab at McMurdo, and we spent a lot of time processing the soil. The soil was partitioned for chemistry experiments, for soil chemistry analysis and soil moisture. And then we would use a fraction of the soil sample to extract animals and quantify the living community there, at least the animal community. And so you can see there's a series of sieves that we would use to wash the soil samples, and then we used a sugar centrifugation method where we would use a high concentration sugar solution in the sample, and then that would cause, the soil particles would sink to the bottom of that when you centrifuge it, and the animals would float on top of the sugar just because of density. You could pour off the animals, and then we would count them on the microscope. So we spent a lot of hours just looking through the microscope, counting animals, classifying them by species, by sex, and by age. And the most abundant animal in the soils is the nematode worm pictured in the center. That's called Scottnema. There were 2 other species of nematodes that we frequently encountered as well. And then we saw a lot of rotifers on the right center there. Deloid rotifers are fairly common in the Antarctic soils, and then tardigrades. Tardigrades are much less common in the Antarctic soils, but they are there. And this one in particular that's pictured here is a large predatory tardigrade. And one of the things that we sort of anticipate will happen as temperatures warm and community structure shifts, that these tardigrades will probably become more abundant. Right now, most of the nematodes, tardigrades, and rotifers that are there are all primary consumers feeding off of bacteria and things in the soil directly, but predators will probably play a bigger role moving forward as temperature warms. In terms of outreach activities, the bottom right picture is from Observation Hill, just next to McMurdo Station. So I spent a lot of hours while I was there up on the hill Skyping with classes. That was a lot of fun. The kids could see the icebreaker in the background and the research vessel in the background, and it was fun to talk to students in classrooms and have them ask questions about penguins and polar bears, which is what they always ask questions about. But it was a lot of fun. And then some of the things I've enjoyed doing here locally, I've been doing quite a few presentations at local elementary schools, and this particular picture in the bottom center was at a scout group. But I've been taking these mock-ups of the tardigrade capturing equipment that we use. So we use a little metal loop called an Irwin loop to actually pick tardigrades out of the samples, and then we place them on microscope slides so we can look at them better. And so I made some big plexiglass microscope slides and some big Irwin loops out of coat hangers. And then I have little plush tardigrades that I have elementary age students go, and they do a little relay race where they try to pick out the tardigrades and put them on the slide and see who's been fastest. And while they're doing that, I I start up the microscope hooked up to a camera, and I pick out actual tardigrades on the slide, and so it's been a lot of fun to have a live tardigrade up on the screen crawling around, and after they do their little relay race, then I get to talk about the actual tardigrades and how just some of their biology, and the kids get really excited seeing it crawling around on the screen, and ask lots of questions. It's been fun. I've done a few other sort of community type things. I've done a presentation at our local library and a few other community groups that I've been presenting at, as well as here at my school. And then I've got a state CTE, Technical Education Conference, coming up that I'm presenting at in a couple months. And then a few radio and television interviews and things that I've been doing as well. In terms of lesson plans, I'm awaiting we sent some soil samples from Antarctica back on the ship. They should be here pretty soon. And I'll be using those with my students. And I'm going to have them comparing the tardigrades of Antarctica to the tardigrades that they collect here locally. And so I've been working on a tardigrade identification sort of lab with a dichotomous key. And then I'm also trying to develop a sort of abuse a tardigrade lab where they get to take tardigrades, let them go into their inactive state. It's called a ton, and then expose them to extreme environments, whether that's like freezing temperatures or high doses of radiation or something like that, and then see how well they survive. And so those are kind of the lessons that I'm working on right now.
All right, very cool. I love the exaggerated plexiglass microscope slide thing. That's really creative. That's fun. Okay, I'm gonna stop sharing for a moment because I believe Judy told me that Byron's on.
Yeah, I'm here.
All right, and just before I have you talk in a moment, Byron, somebody's on the phone. I'm trying to figure out who's on the phone. Who's the phone person?
I'm on the phone.
Is that Jim?
Yes.
Oh, okay. And we also still have Randy. Do we still have you?
Yeah, I'm here.
Okay. So what I wanted to find from the researchers that are able to join us, if there was anything you wanted to add. So Byron, we'll kind of go backwards. We'll start with Byron.
Okay.
Jim, and then Randy. So is there anything you want to add to the perspective of working with the teacher for the group of the cohort, or anything you want to share?
Well, maybe just a couple things real quick. We super appreciated Josh's ability to help, make our project bigger and expand it and communicate it, get it out to a lot of people. He's a fantastic science communicator and really did a great job helping spread our message of love about soil ecology in Antarctica. And the other thing we really appreciated about Josh is that he brought a really nice complementary suite of expert skills into our laboratory. And he was what we call our +1 that season. He was like just a super addition to our team. And so it was fantastic having him there for a lot of reasons, just because of his incredible skill set, both as an educator and also as a scientist. It was great having him.
All right, thanks. All right, Jim, is there anything you want to add to what Kate presented? And we do have Rick's slides. We'll share them in a moment, but he's not with us on the phone. Jim, are you there?
Yeah, hi. Can you hear me?
Now we can.
Okay. Yeah. So, I think the thing you saw from Kate's presentation is he was one of the few team members who could operate in any orientation. So that was quite helpful. So whether on her hands or laying down in a trench. So I think, you know, what the experience that makes it so valuable is you get a chance to see that actually a lot of science is improvising, especially in remote environments. So there were a number of things that were challenges. Kate got to see how we deal with that. The travel was especially bad this year, so you know, that's another aspect that you can't necessarily plan for. And Kate did a fantastic job with all the videos and worked really hard. So we appreciated it, and we have a number of efforts that we're going to involve her with. So from our perspective, it was a real success. Excellent.
All right. Yeah, I know she's going to see you up there soon, which is awesome, and kind of continue that ongoing collaboration with IceCube. How about Randy? Anything you want to add about working with Kara?
Yeah, so Kara was awesome. I think she was even more organized than most of us, the scientists, in large parts of the cruise. Was really great, and I think she was also another good mentor for some of the graduate students. There were only a few like more senior scientists on our cruise. I was sort of like a mid-level person, and Kara was just, she's such a great scientist and just teacher and mentor that I think it was really an asset to have her there, even just for the other graduate students on the cruise. So that was really awesome. And then luckily, Kara and I only live about an hour and a half away from each other. So it's been nice because I've gotten to hang out with her a bit after our expedition, work on some of her lesson plans with her, and just kind of chat and follow up. And she's just so thorough and awesome. And she was really bright, just a really bright spot on our cruise. We got stuck in ice on the ship for about a week, and some tempers were starting to fray a bit there at the end. And Kara was always so positive and just so excited to be there and in that environment. So it was really great.
Excellent. All right. Let me see. I'll show Rick's slides, and then I'm going to come back to the alumni here. And let's see. All right. Just so that we have the slides in here. This is, I believe, and since, I don't know, Jim, there's a picture of Jim, and I don't know if Jim wants to talk about these slides, but since he probably can't see them, probably not. We will just kind of show, I guess, what Rick did. And I don't know, Judy, did he send any notes with his things?
No, there's some text on his future slides. So.
Okay, I'll let you read it because I can't see that.
Oh, okay. So, well, yep. So this one has 3 photos, and it says, "What did we do?" We packed and shipped the neutron monitors to Jang Bogo Station. And he says, "I moved a bunch of lead. And the neutron monitors helped study cosmic radiation primarily from the sun." And then it shows the neutron monitors exposed, time to get the lead out, and I actually can't read the, let's see, and tube repairs. Next slide. It says, "I also got a chance to help dig a few seismometers out of the McMurdo ice sheet. They are used to study the stability of the sheet." Next slide. Now what? So in outreach since then, I have been presenting to different groups in my district, middle and high school science teachers, the school board, Science Honor Society, teachers organizations, DMAPT, AAPT, and at other venues. Preparing, and here on the left-hand slide or picture, preparing for a talk with students and high school teachers at Michigan State University. And the right-hand photo, preparing for a talk sponsored by NASA Office of Education. And I think that's it.
All right. And Jim, is there anything you want to add to the pieces about Rick?
Can you hear me now?
Yep.
Okay, yeah. So we really worked hard. So we were delayed about 4 days getting down there, and then we moved about 25 tons of stuff in 5 days. So Rick earned his keep.
Is there anything that you and Rick are going to work on in the future or you've heard about?
We worked on lesson plans. We don't have any next step. I've been kind of crazy busy since I got back, so I haven't had a chance to connect up with them. We'll try to get something.
Okay, fair enough. All right, I'm going to mute you again there, Jim. All right, very good. Let's see. Before I go into the next little bit, which is just kind of the end, I gotta say I'm really impressed with everything you guys are all been doing. It's amazing. I wish I could take you back to the first time at orientation when I had to hear you describe your research project. And we had to go around with the microphone, and how over the course of the week you got better and better. But even so, you guys are like pros now. It's just like you're like do, and we did this, and we're gonna do this, and you're not like going, I don't know, I don't even know how to tie my shoe anymore at the end of this orientation. But it's a really amazing transformation to watch your mind shift from one of those from that time to here we are a full year later, and really exciting to see all the cool things and to hear your researchers really speak highly of you and your value to the whole science community. That's really what it's all about as well. So good job, big kudos to all of you. I wanted to also thank our alumni that have been kind of supporting you. Armando and Dominique are here, but there's been others I know that have come in and out over the year that are supporting this particular group. And, it's just nice to always have them around, even if we don't get to hear from them as much. But so just a good thank you, both of you, for just even joining tonight and sharing your daughter with us there, Dominique. So cute. Before I go to this next slide and have to share again, Armando and Dominique, is there anything either of you want to share with the group, or you can even give an update on what you've been doing if you need to real quickly?
I just want to say how amazingly blown away I am by the teachers this year. They have been so much fun to follow, and I have learned so much from their expeditions, and I'm just amazed by all of the wonderful things that they've done. And I'm actually really looking forward to using a lot of their projects. I can't wait till they're up on the site to use with some of my students.
Yeah, I'm with you. Excellent. Armando, anything you want to add?
Well, great job, everyone, and it has been really enjoyable being able to attend this webinar. Really enjoyable.
Cool, thank you. Okay, now let's see. I gotta go back to sharing my screen again. So before we, I think that there's only just a few more slides here. I can't tell. I hate not being able to tell what's going on, but anyway, there's just a few things that I want to remind you about. Again, this webinar is really just to kind of see where you all were, get a sense of what you've been doing and where you wanted to go. And I think you all did a fantastic job. And like Dominique, I'm excited to see, I've gotten a really good taste of what the Arctic group has been doing. So I'm excited to see all your ideas that you've had and things that we've been trying in your classroom come out as lessons in particular. And so kind of that's the reminder there, is to remember finishing up some program requirements. And I know everybody's at different stages, and some of you we harass more than others, but that's okay. You're all doing a fantastic job. Another thing to remember is that there's an evaluation this spring, both actually for you and also for your students and also for your researchers. And I think we talked about it on all your post-field calls, but basically sometime starting in May, unless it's sooner with your students, you should be getting a link to an evaluation to have your students do that post survey with them. Like I just mentioned, there'll be an alumni survey as well. And so Dominique and Jim Madsen, he probably gets so many links to all these surveys, both current and post ones. And Armando, you should be getting an alumni survey also this spring. Your expedition pages are going to be there forever, and so feel free to keep using them as you do things this summer, or if you have a presentation or a community event that you want to chat about, or something that's even not related, but maybe I know there's some people that are doing like that National Geographic thing, or going on NOAA Teachers at Sea. Feel free to make and use those expedition pages and share, kind of giving us an update of what you're doing out in the world. It's fun to kind of track that and stuff, and see how it all goes for you and what's next in your life. There's lots of social networking tools, and I know some of you are really active in that area. Continue to do so. It's a great way to connect with the not only your cohort in the past alumni, but as you know, there's a new group out. And in fact, I think the Arctic group, Adina and Jennifer, are leaving in the next couple of weeks. So if you want to have your students, if you need something for your students to do, you can have them start posting questions to the Arctic group. That will be a NASA Ice Bridge project, and Team Squirrel is back at it again. Travel request, I think most of you have done pretty good. Some of you that have just gotten back from expeditions might not be on your radar, but if you're thinking of going to a meeting this summer, and same with researchers, if you're thinking that there's a team meeting or something coming up summer or fall next year, and you thought, wow, it would be really great if Tim could join or Josh could join this or whatnot, make sure you put in a travel request, and it can go both directions. So researchers, we can send you to the classroom or to the community where the teacher is, or to a conference with the teacher, and vice versa. So if a teacher needs to go see what's happening in the lab and get a better sense of kind of post-field expedition activities, please take advantage of that. I don't know what the other is. I can't think of what it would be. PolarTREC, well, we'll see where it goes. I'll keep you posted. I was unsuccessful in my last PolarTREC proposal that I submitted before Christmas. Didn't even make it in the door because I buggered up the actual RFP and some of the requirements. So it never even got reviewed, and it was my fault for sure. So we'll try again, and I have a talk with my project manager coming up here next week. So we'll see where we are, but I'll keep you posted. We're good at least for 2017-18 and the group of teachers that are headed out this year. So we'll keep you posted on that. Judy, am I forgetting anything there?
Nope, that sounds great.
Okay. Again, if any of you are going to meetings and you want to share this flyer, you know, I don't know if we put it in a teacher's manual, but it should be there. An updated one in this upcoming cohort. But this is a good thing to share. It's two-sided. So let us know if you're going to something and you need a lot of copies. We could probably do it on our end, but otherwise, if you need the PDF of this, I can give it to you and you can run copies off of them. And there are some other meeting swag things like stickers and bookmarks. And of course, there's the ECW kit gear. If you do a really big meeting, I actually have, I'm going to stop sharing. I actually have a banner that I can send. So if you're doing something really big and you think I need to have big stuff, let me know and we can send it to you. And of course there's the ECW kit as well. So don't be afraid to ask for things as you need them.
Can I ask a question?
Yes.
I'm wondering about potential AGU, and I know with us being with NASA, is that potentially a possibility for us to get some funding for that if we got
for next year? Yeah, that's fine. Yeah, just keep reminding me. And related to that, seems that I think everything right now is still in the sessions stage. Like AGU is about to close their sessions for their fall meeting, and I think the oceans one, so if you're an ocean related, they're going to be, I think their call for sessions is going on right now, but there's usually an education component to both of those, the AGU fall meeting as well as AGU Oceans. And I think the next AGU Oceans is 2018 in Seattle. I could be wrong about that, but pay attention to those calls that when the abstracts come out, or if you're like, hey, I want to go, let me know. Yeah, all of that's fair game. So even if you were had NASA funding, it's fine. Any other questions or thoughts or things from people?
Janet, I just wanted to say thank you. Again, I know that it's been brought up several times, but Janet and Judy, and of course we kind of overlapped with Sarah, we've been so well supported going to one of the most remote locations on Earth. And I mean, as Jim was saying, like expecting the unexpected is definitely part of it, but everything has been planned so well that it's crazy to go to Antarctica and not be super worried about it. But that's like a huge kudos to you guys that everything just goes so smoothly. So thank you again.
You're quite welcome. I'm glad that it worked out. And I will tell Sarah hello, but she is on social media, so feel free to, ping her also and say, we miss you. It's okay.
As a total side note, I'm presenting at NSF in a few weeks. So if you need to, get a good word in for funding, you just let me know.
I forgot about that. Yeah, you need to remind me.
Schools right across from NSF. So Katie, Sherry, and I are both going there for a presentation.
Yeah, actually, yeah. Will you send me an email about that so that I can remember to give you some talking points?
Sure.
Yeah, that'd be great. Okay. Anything else?
Wait. One other question. It's
Okay.
David. Sorry. So listen, when we go to these sorts of conferences like NSTA right now, and or AGU or EGU or any number of different things, is there a way for you, Janet, to give us things to hand out during the presentations, like a postcard that says, this is where you should apply, or anything other like that? Because even like, with me and Nesta or NAGT or any of these other organizations that we all belong to that do have tables, they would gladly put out propaganda from PolarTREC if we had it.
Yes, I think that I have some stuff. I don't have like the bookmarks are an easy one. I don't know if I have any more postcards. But I got stickers. I got that flyer. Like if you need really a lot of them, 50 or more, I can get those and send them to you and stuff like that. So yeah, just give me some time though, because I can't do any of that. Some of that stuff's here at my house, like actually at my house, and some of it's up at the ARCIS office, and or I have to have it printed off or whatnot at Dateline. So
that's great. It wasn't a problem. I just wanted actually provide it, because
Yep.
obviously you can't be at all these conferences, but we sure the heck are.
Yeah, and that does remind me about outreach. Continue to track your outreach online, you know, preferably with the web form, because that's like immediate. But, you know, if you're doing it over here on the spreadsheet and then you need a day to enter it in on the online, that's fine too. And for those of you that still have lessons and STEMS experience reports to do, we've changed from the orientation this year. We changed how that process goes. So when you think you're ready for your lesson or your STEM experience report, contact us and we'll direct you to the new instructions on how to do that, okay? Basically, it will be a little bit more work on your part, but it shouldn't be much different than creating a journal. It's the idea that you have the headers, the markdown language is in there. It's a cut and paste job, basically. But anyway, those were kind of my things. But yes, if you're going to meetings and still doing outreach, or there's media coverage and all that stuff, keep sending it and adding it to your, you know, repertoire of stuff, and feel free to ask for things if you need them. So, well, sure. So, I actually just looked at the time and I actually have to go to the bus stop. So, is there anything else that